we are continuing the 4 keyboard classes. We have been dealing with motion, motion in a straight line. That's rectilinear motion. Rectilinear motion in a straight line. We are going to introduce now curvilinear motion. Curvilinear motion. That is motion in a curve. Curvilinear motion. In a curve, when a motion is, or when whatever body is moving and encounters a curve, immediately encounters a curve, what happens is that as it gets to the curve, it will be changing direction as it's going around the curve. That means the velocity now, as it's going around the curve, there will be 2 types of velocity. Because when the velocity is at acceleration, for that matter, when the velocity is changing the direction, the velocity may be the same, but direction is being changed. And being that velocity is a vector, as it's changing direction, it's no longer the value. If velocity A was 2 meters per second in one direction, and it changes to another direction, velocity B now, 2 meters per second. The 2 velocities are not the same because directions are not the same, even though quantitatively they are the same. So in such a case, we look at it how in such a situation where the velocities are the same in quantity, but they change. And whenever there's a change in velocity, acceleration will occur. So as far as there is a change here, acceleration will occur. Even though the quantities are the same, but the direction changed. So as the direction is changing, acceleration will occur. So the kind of acceleration we have here is what we call normal acceleration. Normal acceleration. This acceleration, we find it, normal acceleration, to be equal to the velocity, that velocity squared over the radius of the curve. But if at any particular point, because at any particular point, we take the velocity at that particular point, that velocity at that particular point, it changes, there's a change. So we don't talk of acceleration along that line, because along the line, in actual sense, the quantities are the same. So we talk of normal acceleration, which we get to be equal to this, because we know that when velocity is the same, does not change, acceleration is 0. But in this case, why it is not 0 is that the velocity was changing because direction were changed. So the type of acceleration that occurred here is normal acceleration, which has to do with the radius to the center. It is a kind of centripetal acceleration. It is acceleration that drags the moving object to the center. The acceleration that drags the moving object to the center, because the velocity were the same in quantity, but was changing in direction. This is a vector. So the type of acceleration that drags it to the center is what we call normal acceleration, and is equal to the velocity squared over the radius. But when we now talk of the acceleration that occurs as the vehicle, as the body changes direction and changes and the quantity changes, we talk of what we call tangential. This normal acceleration. We have tangential acceleration, which is in this case A with small t, tangential acceleration, whereby it is the same thing of what we have been in linear motion, which if the motion starts from rest, the tangential acceleration is equal to the velocity over time, which we already know over time. So we will look at these 2 types of acceleration that occur in a body that is in motion there are two accelerations. The reason is that even though the velocity may be equal in quantity, but for the fact that due to the nature of the curve, the velocity continues changing direction, and as such, it's no longer the same because it's a vector. And as such, and whenever velocity changes, acceleration will result. Because the fact that the velocity didn't change quantity, and acceleration must result in this case, there's an acceleration that drags the material to the center, which we call the normal acceleration. And that is equal to the velocity squared over the radius. While the acceleration that occurs along the line or along the route of movement, as velocity changes in value, the other one, velocity does not change value. It doesn't change quantity. In this case, when it is changing quantity, we now have tangential acceleration that is beside along the curve. And that tangential acceleration is equal to the velocity divided by time, which we know already. Let's also look at questions and see whether we can make use of this. So the first one, it says a vehicle moves at a uniform speed. A vehicle moves at a uniform speed of 3 meters per second on a curved section of a road having a radius of 20 meters. Determine the normal acceleration of the car. Normal acceleration. So it is simple. Normal acceleration is equal to v less velocity. Velocity divided by the radius. And in this case, it said that the velocity, the car was moving with a speed of 3 meters per second, and the radius is 20 meters. So that is 3 meters per second over 20. As simple as this. The normal acceleration. The question says we should get the normal acceleration. So if I got 10.45. Is equal to 10.45. That is the normal acceleration. 10.45 meters per second. Meters per second square. That is the acceleration. That's the acceleration. Thank you very much. If you look at this, the question says a vehicle moves at a uniform speed. Moves at a uniform speed of 3 meters per second. We say the speed is uniform in quantity. A uniform speed of 3 meters per second on a curved section of a road having a radius of 20 meters. Determine the normal acceleration of the car. A vehicle moves at a uniform speed of 3 meters per second on a curved section of a road having a radius of 20 meters. Determine the normal acceleration of the car. Simple. Normal acceleration is velocity squared over the radius, which we have as 3 is the velocity 3 meters per second divided by the radius, and I got it to be 0.45, not 10.45. 0.45 meters per second. 0.45 meters per second. That is as simple as this. I thank you.